Hello. Today I'm going to talk about a couple of things from chapter 5, starting with section 5.4, talking about differentiation of exponential function. Okay, in particular, a natural exponential function is a good example. So let me show the derivative rules for a natural exponential function first. So for y equals e to the x, which is called a natural exponential function, there are two rules for it. Number one, derivative rules, d over dx of e to the power x is e to the power x. The second one is a chain rule. If the exponential is just not x but any other function, then we have got to use the chain rule by making u substitution. So d over dx e to the u would be e to the u times u prime. This is a chain rule. Okay, so with that in mind, let's do a couple of problems here. So we can have example from both of this definition given to us. So say number one, equation, find f prime of x, which is derivative, using f of x equals to e to the power x minus x squared. Okay, so use the rule whatever applies. So what I'm going to do is show you the derivative, which is f prime of x is d over dx of the first function to e to the power x minus d over dx of the second function, which is x squared. Now I will apply rule number one from this. 2 is a constant, so they remain as a constant, but derivative of e to the x is e to the x. So this will just be 2 e to the x. Minus, there's no exponential here, it's an algebraic function, use power rule of derivative, so this becomes 2x. So the final answer of the derivative is just like that. Okay, so this is one example for using this one. Now let's go to the second one where the chain rule can be applied. So the problem 2, f of x is going to be e to the power, on the top is 2x squared plus the x. Now as you can tell, it's just not e to the x, this is another function added to this one, so this will require a chain rule, which means I'm going to have to make a u substitution. Let's call it a e to the u, where u will be identified as 2x squared plus x. And then going back to this chain rule here, you see this is e to the u times a u prime. So if you identify what is your u is, which is the top exponent, then u prime will be just derivative rules as a power rule here, which will be 4x plus 1. So with that said, let's use our chain rule here for this. So let's start with the notation of the derivative, which is f prime of x. We say d over d x of e to the u actually, and that is what? U prime or times a e to the u prime and e to the u. So then it will become, I'm just gonna, oh sorry, this is not x, this is e to the u. Okay, so now e to the u will remain here. U prime is 4x plus a 1. Finally put the u substitution back in place, so final answer would be e to the 2x squared plus x, and then you can put in a parenthesis 4x plus 1, and this is one of the expected final answer for it. Okay.